So today we'll be looking at inverse functions, and we'll do a question regarding inverse functions. So the question is that, does this function y is equal to x square minus 2 have an inverse? And if it has an inverse, what is that function? And if it doesn't have an inverse, why is that? So the function is y is equal to x square minus 2, and we have to find inverse of this function, or we have to tell that whether its inverse exists or not. So the function is y is equal to x square minus 2, and this function basically is a parabola, because it is a quadratic function, and quadratic functions have a graph of a parabola. So because x has power 2, and this is a parabola, so we know that in inverse functions, when we find an inverse of a function, we interchange the input and output. So the input to our original function becomes the output of our inverse function, and the output of our original function becomes the input to our inverse function, basically, which means that y and x get switched. So as in our original function, x is the input, and we put the value of x in this function, and y is the output, and we get the output, which is y. But in our inverse function, we'll put the value of y of our original function as x, and the input to our original function, which was x, will come as the output of our inverse function, which is y. So if we put 3 into our original function, it gives us the value of 7, because 3 squared is 9 and 9 minus 2 is 7. Similarly, when we put minus 3 into our original function, this gives us minus 3 squared, which is 9, and 9 minus 2, which is 7. So both of these inputs are giving us the same output, which is 7. Now the problem with this is that 7, for this function to have an inverse, 7 will be our input to the inverse function, because it was the output of our original function. So it has to be taken as input to our inverse function. And for inverse to exist, it must generate an output which was the input of our original function. So when we put 7 into our inverse function, it must generate the input to our original function. The problem here is that the inputs were 2. There was an input which was 3, and there was another input which was minus 3. So when we put 7 into our inverse function, we are not sure that whether it should generate 3 or minus 3. We don't know that this value 7 was the output of 3 or minus 3 in our original function. We don't know that. We can't just guess the output of our inverse function simply by looking at 7, because 7 can be the output of 3 or minus 3, because the domain of our original function y is equal to x square minus 2 is real numbers. So I haven't written that. So the domain is x belongs to real numbers. And that's why I have taken the both negative and positive inputs to the original function. So we can't generate the output of the inverse function because we can't tell that where did this 7 come from. We can't tell that whether it was generated from 3 or minus 3 in our original function. And so we can't, the basic purpose of inverse function is to reverse what you have done in your original function. So if you generated 7 from the original function, we must be able to generate the input which gave us 7, but we are unable to do that because there were 2 inputs which generated 7. So the inverse of this function doesn't exist with this domain, that is because this domain involves both negative and positive numbers. This function is defined for both positive 3 and negative 3. And for this function to have an inverse, we must, for inverse to exist, we must restrict the domain of the original function, because currently the domain is basically x, the input which can the values which you can give as an input to the original function, which was x. So for inverse to exist, we must restrict the values of x, because currently the values of x can be positive or they can be negative. And the problem with that is that both of the positive, because there is a square, there is x square in our original function, it generates the same value as an output whether we give it a negative number or a positive number as input. And that is the problem. So we have to restrict the domain of the original function. Either we can make it positive, we can take positive values of x and 0, or we can take negative values of x and 0. So the domain can be x greater than or equal to 0. This will restrict our original function to the positive side of x-axis, and we'll be able to tell that this 7 was generated from plus 3, because the original function would not have a minus 3. It is not defined for minus 3. We can't take minus 3 because the domain is restricted. It has now just positive numbers. So we can find an inverse, and we can easily say that this 7 was generated from positive 3. Similarly, we can take the domain as only negative numbers and 0, x less than or equal to 0, and we'll be able to tell that this 7 was generated from minus 3. So now we'll look at the graph of this function. So I'm using Desmos here, and our function was y is equal to x square minus 2, and we can clearly see that the graph of this function is a parabola. It is a parabola which is opening upwards, and you can see that the parabola is symmetric around y-axis, and the negative and positive values generate the same output. Like we can clearly see that this point So we can see that the whatever we give as an input, this is our x-axis, and whatever value we put as x, it generates same value on both the positive side of x-axis and the negative side of x-axis. So we must restrict the domain. Either we take the positive side of the parabola or the negative side of the parabola, which means positive values of parabola or positive x values or negative x values. And then we'll have one input for we'll have one output for one input. We won't have, when we restrict the domain, we won't have two same outputs for we won't have same output for two different inputs. So if I roughly draw the parabola here, so parabola is somewhat looking like this. So if I take this portion, this, which is a positive side of the parabola, now every x value will have one output. This has this output, this will have this output, this will have this output. So we won't be getting same output on same output for two different inputs. But if we take the whole parabola, this output will be same as this output. So we can see that when we take the whole parabola, or when we take the domain of the parabola as real numbers, this input and this input, both of these values of x are generated same output, which is this. These are same values, and this is basically a hindrance to finding an inverse to this function. And for this function to have an inverse, this output shouldn't be same for two inputs. So we restrict the inputs. Either we take the right hand side of the parabola, like the one in the box here, or we take the left side of this parabola, which is not in the box. And then we can have inverse for the function when we restrict the domain of our original function.